First, I will give you a brief idea what we are going to do today. Then we will actually see the procedure. We are going to prepare two types of solution as usual. One will be a standard solution and other will be sample solution. This you can also call it as test solution. Standard solution is something of which concentration is exactly known. Okay, so two standard solutions will be prepared and two sample solutions will be prepared. Okay, the standard solution will be like we will first prepare a stock solution. इसका concentration पता होगा obviously because it is standard, and then we will dilute stock in NaOH and prepare one diluted solution. Okay, इसका जो भी concentration होगा dilute solution का जो भी concentration होगा the same concentration solution we will prepare in HCl. That is solution in acid. Please remember the concentration of both the solutions are same. Concentration of both the solutions are same. Okay, if my drug is acidic drug, right? So somebody will unmute and tell me so I can hear your voice that if my drug is acidic drug like paracetamol will show more absorbance in NaOH or it will show more absorbance in HCl. Unmute and tell me.
Sir, more absorbance in NaOH.
Excellent answer. Because suppose it is acidic drug, the proton will get abstracted in base and the lone pair, that is the sigma bond between the heteroatom, that is oxygen and hydrogen, that sigma atom will shift on oxygen. So you got one extra lone pair of electron in case of basic solution. Okay, so there will be increase in the absorbance in base, and in case of acidic drug that dissociation, that shifting of sigma bond on oxygen to give you lone pair is not possible because paracetamol will remain in unionized form. So obviously HCl का absorbance, HCl के solution का absorbance कम होगा और NaOH के solution का absorbance ज़्यादा होगा. ओके, नाउ ये तो हमने सॉल्यूशन बनाने की बात की है और उसका एब्जॉर्बेंस कैरेक्टरिस्टिक डिस्कस किया रिलेटेड टू स्टॉक. नाउ फॉर सैंपल, वी सपोज सैंपल इज टैबलेट. फ्रॉम दैट पैरासिटामोल टैबलेट we will prepare similar dilution. We will prepare similar dilution, and after dilution we will prepare a solution in base and we will prepare solution in acid. Now, when we are preparing solution of sample, please consider that we are trusting whatever the label claim is. Okay, we are trusting whatever the label claim is. A label, if it is saying that each uncoated tablet contains 500 milligram of drug, we assume that the claim is right, and accordingly we prepare dilutions. Okay, we will calculate the quantity of powder to be weighed, then we will dissolve that powder in certain volume of the solvent. Okay, so similarly जैसे NaOH और HCl में बनाया था ये solution standard के लिए, वैसे ही हम solution बनाएंगे टेस्ट का NaOH और HCl में. When we are diluting, we will take care that their concentration is not only same, okay, but it will also match concentration that of the standard. Okay, it will be theoretical dilution, because we don't know actual concentration. ये हम predict करेंगे कि हाँ अभी ये ऐसा dilution किया तो दोनों का concentration standard और test का similar होगा. Okay, so I hope you are clear here till here. Okay, so similarly हम absorbance लेंगे test का, which is the solution prepared in basic condition. It will have larger absorbance as compared to solution prepared in the acidic medium. Now, the difference of the absorbance between these two, let us consider as delta A for standard, and difference between these two, let us consider as delta A of test. Can you comment about these two differences in absorbance? Can you compare them and can you comment them? Logically क्या होगा? What should happen? Now you need to unmute and tell. चारों सॉल्यूशंस का कॉन्सेंट्रेशन सेम है. डिफरेंस क्या है? जो लेफ्ट हैंड साइड में दो सॉल्यूशन है वो स्टैंडर्ड से बना है, और जो राइट हैंड साइड में है वो टेस्ट से बना है, दैट इज टैबलेट से बना है. अगर मैं एज्यूम करता हूं कि टैबलेट जो क्लेम कर रहा है वही एक्चुअल में प्रेजेंट भी है, so this is the special condition. Whatever is claimed on the label of the tablet is true. Can you compare delta A of S, that is difference in absorbance of standard solutions, to difference in the absorbance of test solution? Please unmute and tell. I cannot switch my view.
Sir, they should be same.
Excellent, excellent. Logically देखा जाए तो दोनों same होना चाहिए. Okay. If I want to apply Beer-Lambert's law, can I say delta absorptivity of standard, let us not consider path length, okay, multiplied by concentration of the standard. Do you agree with this statement? So I will quickly tell you how it is. See, this is absorbance of standard in base minus absorbance of standard solution in acid. Okay. So it will be, I am ignoring the path length. This is absorptivity of standard in base minus multiplied by path length, which is equal to 1 centimeter, into concentration of standard minus absorptivity of standard in acidic solution multiplied by path length 1 centimeter into concentration of standard. So you can see that CS is common. So can I write this as, in bracket, absorptivity of standard in basic solution minus absorptivity of standard in acidic solution, this multiplied by concentration of standard. Can I write this term as delta AS? Can you please tell me, can you write this as delta AS? Am I right in writing this way?
Yes, sir.
Excellent, excellent. I hope there is no doubt till here. Okay. So, if I can take the reading and calculate delta AS, and because it is standard, I can know concentration of standard. Can I calculate delta AS? Obviously, I should be able to calculate it is by simple cross multiplication or division. Delta AS upon delta CS, I will get delta AS, that is absorptivity of standard. Now, Here you have got value of delta S. हाँ, यहाँ तक समझ में चलो that you have calculated this one. Now, can I apply the same logic and can I write delta absorbance of test is equal to delta absorptivity of test multiplied by concentration of test. So concentration of test will be equal to delta absorbance of test divided by delta absorptivity of test. Now this it can be observed by using UV spectrophotometry. मशीन यूज करके हम ये डिटरमाइन कर सकते हैं. आपको ये कहां से मिलेगा?
Sir,
Any guesses?
absorptivity value is constant. So delta absorptivity of standard and delta absorptivity of test remain same.
Excellent. Excellent logic. Excellent logic. So this A delta AS and delta AT, they will be same. They will be equal. Excellent. Excellent. So whatever I have got over here, that value I will substitute over here. तो मुझे ये भी पता चल गया, मुझे ये भी पता है. Can I calculate concentration of test? Yes, obviously I can. So I will calculate concentration of test in dilute solution. Then I will multiply by dilution factor to get the quantity of drug in the tablet powder. Have you understood this experiment? Anybody? You need to unmute and tell if you have doubt.
Yes, sir.
Everything is clear? Very good. So I will change the view. अभी ये खत्म हो जाएगा. किसी को अगर स्क्रीनशॉट लेना है तो ले सकते हैं. I will keep it for 2 seconds more, 2-3 seconds more. Okay, now I'm changing the view. Okay, so we will take pure paracetamol and we will make its solution 100 microgram per ml. Suppose मुझे ऐसा 100 ml solution बनाना है. So how much of paracetamol should I weigh and dissolve in say suitable solvent? It may be methanol, it may be water. Water में dissolve नहीं होगा, methanol ही रहना पड़ेगा. So if I want to make 100 ml, now I can switch the window. So you can type down the message. अगर मुझे 100 ml 100 microgram per ml solution बनाना है, so how much of paracetamol should I weigh? The question is, I want to make 100 ml of 10 microgram per ml solution. How much paracetamol I should weigh and dissolve it in 100 ml? Okay, 10 mg is right answer. You weigh 10 mg, you dissolve it in 100 ml, you will get your solution. Okay. So, from this stock solution, I will pipette out 1 ml and I will dilute it to 10 ml using 0.1 normal HCl. Let us call it as solution A. From solution A, I am pipetting out 1 ml, diluting again with 0.1 normal HCl to 10 ml. Let us call it as solution B. Again from this solution, this stock solution, I am pipetting out 1 ml, diluting to 10 ml using NaOH. Let us call it as solution C. From this solution C, I am pipetting out 1 ml, diluting with 0.1 normal NaOH with 10 ml solution. Let us call it as solution D. So what we have done here, we have taken a stock solution, we have prepared one dilution in acidic condition, we have prepared one dilution in basic conditions. Have you understood this part of the procedure? Okay, everyone has understood this. Okay, now obviously now you can type down the message. दोनों में से HCl solution और NaOH solution, This is a repeat question. मैंने अभी कुछ देर पहले पूछा था. Which solution you will answer in terms of solution का name, whether solution B or whether solution D will have more absorbance. Excellent. So everybody is getting the answer. That solution D will be having more absorbance. Okay, let's proceed now. If solution B is having less absorbance, we will keep solution B in the reference cell and we will keep solution D in the sample cell. अभी ऐसे अरेंजमेंट क्यों किया, I will explain. Whenever we take absorbance using UV spectrophotometer, what reading you get on the screen is absorbance of solution in the sample cell माइनस एब्जॉर्बेंस ऑफ सॉल्यूशन इन द रेफरेंस सेल. मतलब ये वैल्यू हमेशा कम रहता है. दिस वैल्यू इज ऑलवेज लेस एंड दिस वैल्यू इज ऑलवेज मोर. So you are getting nothing but difference between absorbance of this solution. Okay, have you understood this part? This is related to machine UV स्पेक्ट्रोफोटोमीटर. हमको एक सैंपल सेल में रखना पड़ता है और एक रेफरेंस सेल में रखना पड़ता है. जो रेफरेंस सेल में जो भी रहता है उसका एब्जॉर्बेंस हमेशा कम रहता है. ओके, तो नॉर्मल सिनारियो में फॉरगेट अबाउट दिस टुडेज एक्सपेरिमेंट फॉर टाइम बीइंग. अगर हमारा नॉर्मल कोई तो एक्सपेरिमेंट है जिसमें हम एब्जॉर्बेंस ले रहे हैं, इन दैट केस सपोज इट इज पैरासिटामोल का सैंपल prepared in methanol. I will prepare the solution of paracetamol in methanol and I will keep that in sample cell. In reference cell, I will keep only methanol. And when I get the reading, it is the difference between the sample cell, absorbance of sample cell minus absorbance of reference cell. Okay, but that is the normal scenario. Okay, that is the normal scenario. Now consider today's experiment. We are using one solution in acidic condition जिसका absorbance कम है and other solution in basic condition जिसका absorbance ज़्यादा है. We are interested in delta A. We are interested in difference in the absorbance. We don't care what the actual absorbance of solution B and what actual absorbance of solution D is. Their absolute value I don't care. What I care is only the difference. So instead of taking two different readings, मतलब two different reading कैसे? सैंपल सेल में सॉल्यूशन डी रखा और बाद में रेफरेंस सेल में ब्लैंक रखा. ये हो गया एक रीडिंग. और दूसरा रीडिंग क्या? सैंपल सेल में सॉल्यूशन बी रखा और रेफरेंस सेल में ब्लैंक रखा. अभी मुझे दो रीडिंग मिल जाएंगे, one for D, one for B. Then I am going to subtract of absorbance of D minus absorbance of B. Then I will get delta A. ये क्या हो गया? लंबा प्रोसेस हो गया. ओके, मतलब सब्सट्रैक्शन भी मैन्युअली करना है, दो रीडिंग लेना है. ये अच्छा, इससे अच्छा तो मैं यही करूंगा कि रेफरेंस सेल में सीधा सॉल्यूशन बी को रख दूंगा और सैंपल सेल में सीधा सॉल्यूशन डी को रख दूंगा और मुझे डायरेक्टली एब्जॉर्बेंस मिल जाएगा. हैव यू अंडरस्टूड दिस पार्ट एवरीवन? हैव यू अंडरस्टूड दिस पार्ट? यस, एक्सलेंट. सो फॉर मी एब्जॉर्बेंस ऑफ NaOH solution of standard, यहां पे ब्रैकेट लिखना चाहिए था, minus absorbance of HCl solution of standard is equal to absorbance of standard solution in sample cell minus absorbance of standard solution in reference cell. I hope you understood this statement. Actually it is repetitive, दोनों left hand side right hand side actually same ही है, but I wanted to focus on this logic over here. Okay, so I will clear all the ink on my slide. I hope you understood. If you have any doubt, please ask me. or just type down no doubt, so I will proceed. Excellent, there is no doubt. So this was regarding your standard solution. अभी जो मैंने बोला ना, ये सब किया जो हमने, वो यहाँ पे प्रोसीजर में दिया है. Okay, you can see that in the procedure itself they have mentioned what is to be kept in the reference cell and what is to be kept in the sample cell. Okay, one thing I forgot to mention, you will take absorbance at 257 nanometer. Okay, and then you will calculate in the last step delta absorbance for standard. Now, by logic, what do you think, what should we do next? What should we do next? Excellent, sample. तुषार इज सेइंग करेक्टली. अभी हमने स्टैंडर्ड के दो सॉल्यूशन बनाए और उसका डिफरेंस लिया. अभी हमको सैंपल बनाना है. अभी सैंपल हम किस चीज से बनाएंगे? हम टैबलेट से बनाएंगे. अगर टैबलेट है तो हमको उसको पाउडर करना पड़ेगा. अगर टैबलेट को पाउडर करना है तो वो पाउडर क्वांटिटी में से थोड़ा सा पाउडर निकालना पड़ेगा. सो अ फिक्स्ड क्वांटिटी टू बी वेड. ओके, सो नेक्स्ट पार्ट इज योर calculation of weight of tablet powder. Calculation of weight of tablet powder. उसके नीचे लिखो weight of 20 paracetamol tablets is equal to 12.020 grams. उसके नीचे लिखेंगे average weight of paracetamol tablet is equal to. Tell me average weight, what it is. Calculate and tell me. You will tell both in grams and milligrams. Excellent, Sajjad. 0.601 grams. How much in milligrams? Excellent, 601 milligram. Excellent, people. Very good, very good. Okay, so 0.010 gram or 601 milligram. Now, next line, write down each uncoated tablet contains 500 milligram of paracetamol. Each uncoated tablet contains 500 milligram of paracetamol. This is label claim. Now, weigh a quantity of tablet powder equivalent to 50 milligram of paracetamol. So, you will calculate the tablet powder weight equivalent to 50 mg. You calculate and tell me how much it is. Okay, so everybody, I assume, are getting right answer. It is 60.1 milligram. Actually, the calculation was pretty much easy. Now, please consider, if you have done calculating for standard, when we started the dilution of standard, we started with 10 milligram. We started with 10 milligram of the standard drug. But we are starting with 50 milligram of paracetamol in tablet powder. You understand this difference between the starting point of standard and starting point of the sample? स्टैंडर्ड के लिए हमने 10 मिलीग्राम से चालू किया था और सैंपल के लिए हम 50 मिलीग्राम से चालू कर रहे हैं. डू यू अंडरस्टैंड दिस डिफरेंस? जब हमने ओके, आई विल चेंज द स्लाइड. प्रीवियस स्लाइड देखते हैं तो आपको शायद समझ में आएगा. देखो, यहाँ पे हमने जो चालू किया था वो हमने क्या किया था? 10 मिलीग्राम ड्रग लिया था पैरासिटामोल प्योर स्टैंडर्ड के लिए और उसको डिसॉल्व किया था 100 ml में टू गेट 10 माइक्रोग्राम. ओके, so we started with 10 mg, but for test we are starting with 50 mg. और उसका what I'm trying to say, what I'm trying to explain is the dilution scheme for the test will be different than that of standard, but ultimately we are going to get the same concentration over here. जैसे solution B और solution D का जो concentration है वही और similar concentration we will get for test. The point that you should take from this discussion, last 3-5 sentences, is we are taking different dilution scheme for test than that of standard, but ultimately we are aiming for the same concentration. Okay, have you understood this? हमको concentration वही बनाने का है. बट वी आर स्टार्टिंग विथ 50 mg, तो उसका डाइल्यूशन स्कीम अलग होगा. ओके ओके. सो हम क्या करेंगे? टू स्टार्ट विथ वी विल टेक 50 मिलीग्राम ऑफ पैरासिटामॉल and will transfer that to 50 ml volumetric flask. ओके. अभी 50 ml ऑफ पैरासिटामॉल किस में प्रेजेंट है? 60.1 मिलीग्राम ऑफ टैबलेट पाउडर में. सो वी आर ट्रांसफरिंग दैट इनटू a volumetric flask of 50 ml. We will add 25 ml of methanol and we are going to shake it for 20 minutes. Any guesses what is role of methanol? Extraction, yes. So yes, both answers are right. Methanol is acting as the solvent for paracetamol. So paracetamol will get extracted from its excipients, okay, into the solution. I hope you understood this part. Okay. Now we are going to make up volume to 50 ml. So we had taken 50 mg of paracetamol and we are dissolving it in now 50 ml of methanol. So what is concentration of this solution now? Tell me in milligrams as well as micrograms. 1 milligram per ml is right. How much in micrograms? Ruksar, think again. Mohammed, you are writing quantity, you are not writing concentration. Same with Charvi. It is 1000 microgram per ml. Excellent, Sajjad. Very good. Okay, now people are getting the answer and they have understood. I hope so. So it is 1000 microgram per ml ka solution. Okay, I will clear the ink on the slide. Okay. Now we will filter the solution to remove any particulate matter that is present. Let us call at this solution as solution E. ABCD हो चुके हैं, तो उसके बाद आता है E. So this is solution E. Now this solution E, we will consider this as stock solution of test. Its concentration is 1000 microgram per ml. Before diving into the concentration of and dilution of stock solution, आपने अभी टैबलेट का कैलकुलेशन किया. ओके. उसके नीचे आप लिखेंगे डाइल्यूशन स्कीम. प्लीज राइट डाउन डाइल्यूशन स्कीम फॉर स्टॉक solution. Dilution scheme for stock solution. Then you will write down the dilution scheme what is given on the slide. इतना ही लिखेंगे आप. You will take down this dilution scheme, and once you have taken down the dilution scheme, everybody will calculate concentration of B and concentration of D. And let me know in the chat box what is the concentration. वो जो concentration का calculation है वो रफ जर्नल के लास्ट पेज पे करो. कंटिन्यूएशन में सिर्फ डाइल्यूशन स्कीम लिख लो. ओके. Please calculate concentration of B and D and tell me in the chat box. Charvi, Apurva, Ruksa, Siddhi, Sushmita, Pragati. Excellent. So if this is the concentration of my standard solution, what should I aim for test solution? Should I aim for 1 microgram per ml in acidic and basic solution? Ideally, it should be same for standard and sample. So from the 1000 microgram that what we have got, we will try to dilute to get 1 microgram per ml in both. Okay. So we are starting here with 1000 microgram per ml solution and our target is 1 microgram per ml solution. 1 microgram per ml solution. So Let us see how we can dilute. From this stock solution of test E, we will pipette out 1 ml, dilute it to 10 ml with 0.1 normal HCl with solution F. One step. So this is 10 times dilution. Any guesses what will be concentration of solution F? Mohammed is telling 100 microgram per ml. Excellent. So 1000 microgram per ml solution diluted 10 times, you get 100 microgram per ml solution. Excellent. Okay, from this solution F, let us call it as solution F. This solution is solution F. From that pipetted out 10 ml. From that pipetted out 1 ml from solution F, diluted to 10 ml again with 0.1 normal HCl. Let us call it as solution G. Any guesses what will be concentration of solution G? Ten microgram per ml. Okay, Muhammad is very quick in answering. Okay, very good. Now, अभी 10 माइक्रोग्राम पर ml तो मिल गया, अभी और 10 ml का डाइल्यूशन करना है. So we will take 1 ml, dilute with 0.1 normal HCl to 10 ml. So you will get solution H. We got our 1 microgram per ml solution in acidic medium for test. Have you understood till here? Everyone, have you understood till here? Yes. Excellent. तो अगर हमने ऐसा सॉल्यूशन प्रिपेयर किया है एसिडिक मीडिया में, we will carry on with the same dilutions to get solution K. Take 1 ml, dilute to 10 ml. From that solution I, take 1 ml, dilute to 10 ml to get solution J. From that, take 1 ml, dilute to 10 ml with solution K. All these dilutions are done with NaOH in basic media. So, as we had done for the standard, we will keep solution H in reference. We will keep solution K in sample. So, we will take the difference to get delta A of test. Have you understood this part of the experiment? Excellent. 50 milligram we had taken and we had diluted that to 50 ml and then put this in square bracket. Let me erase the extra ink on the slide. So below dilution scheme, please write down calculation of dilution factor. When you're calculating dilution factor, you need to consider this first step also. Huh? You need to consider this step also. So basically, from this 50 ml, you are pipetting out 1 ml. So this is how you will consider. Please tell me what dilution factor you are getting. Excellent. So 50,000 is the right answer, and it is not complicated also. Okay, excellent. So 50,000 times is your dilution factor. You need not calculate the theoretical concentration here because we are going to compare the quantities, not concentration, at the end when we calculate the percent content. So just 50,000 times dilution factor. Okay, let's proceed. Next part, write down observations. Next. Now for everybody I will give you observations. आप ऐसे लिखेंगे. These are your roll numbers and your observations. Please take down your observations. Then I will let me know when you are done. These are as per your roll numbers. Okay, after observations comes calculations. Okay, कैलकुलेशन मैंने एक्चुअली आपको बता दिया है. देखो कैलकुलेशन में पहले लिखेंगे फॉर स्टैंडर्ड सॉल्यूशन डेल्टा ए इज इक्वल टू डेल्टा स्मॉल ए मल्टीप्लाइड बाय पाथ लेंथ multiplied by concentration of standard. So delta A over here, small a will be equal to delta capital A divided by concentration of standard. B is taken 1 centimeter. Below that you will substitute the values, and next on next line you will calculate value of delta A. After that, for test solution, delta A is equal to, if you want you can write down this way also, delta A of standard and delta A of test. So it will be easy for you, okay, to identify which value is which one. Okay, delta A of T is equal to delta A into B into C. So concentration of test is equal to this much. So whatever answer you are getting, it will be in micrograms per ml. That depends on concentration. Whatever you are getting depends on what concentration unit you are using over here. If you are using 1 microgram per ml, over here the answer you will get over here is also in micrograms. I hope you understood what I am trying to tell. Okay, if you have understood the calculation, please proceed for it and tell me what concentration you get for your test. Okay, so I am keeping this calculation slides on. Proceed for calculation and everybody will tell me your concentration of test. Excellent. For people those who are getting the answer, I am writing down next what to do. Acha, before I write what to do next, can anybody guess what to write? Those who have completed can answer. Multiplied by dilution factor. So excellent. So you will write quantity. Don't write short forms, huh? You will write full form. Quantity of paracetamol in tablet powder will be equal to C test multiplied by dilution factor. Okay, so you will get quantity in micrograms per ml. You will get micrograms, not concentration. You will get quantity in micrograms. Please convert that into milligrams. Convert that quantity into milligrams. Now, after this, next step is to calculation of percent content. Calculation of percent content. Percent content will be equal to, again I request you not to write short forms. मैं लिख रहा हूं क्योंकि मुझे ये सब लिखना पड़ रहा है और it is difficult using laptop keyboard. Okay, so this is practical quantity divided by theoretical quantity multiplied by 100. So you will calculate percent content in this manner. Excellent. People have calculated percent content also. I will add one extra step here. If you know percent content, can you know the quantity of paracetamol present in one tablet? Can you find out? Yes. How can I find out? My label claim is 500 mg. You can unmute and tell, or you can type it down. Okay, I'm not getting any message. Okay, so Mohammed has typed down 500 mg के लिए is equal to 100, therefore multiplied by milligram. Acha, I don't understand what he is trying to tell, but anyway he has tried. Okay, so after calculating percent content, you will write quantity of paracetamol in tablet is equal to 500. 500 क्यों? It is the label claim multiplied by percent content. So percent content divided by 100. Okay, so if it is say 90%, yes, 4500 it will become. Where you will get your answers in milligrams. You will get your answers in milligrams. Okay, so this is your result statement. The given sample of paracetamol per tablet contains milligrams of paracetamol IP, and second is percent content of given sample of paracetamol tablet was found to be so and so percentage. Uh, I will give you 5 minutes to complete it. Then I will show you whether your results are matching with the results which I have calculated. So, Nalsa message. Okay, so your percentages are matching. Okay, now it is almost 11:40. I will tell you what I have found out. Just a second, I will share that slide. I have prepared this Excel sheet for calculation. Just check whether my calculations are matching with your calculation. This is your roll number. I will copy down the roll number column again at the end, so it will be easier for you to find. Okay. So this is how I have calculated. Now, anybody of you, all 22 students, tell me what advantage this difference spectroscopy has. What is special about this difference spectroscopy? हमने अभी एक क्लास टेस्ट भी दिया है, बताइए. What is special about this difference spectroscopy? अच्छा, okay, ठीक है. Only 2 readings. That is one advantage. Very good, son. 2 ही रीडिंग लेना है, ज्यादा नहीं है. Accuracy is improved. How come accuracy is improved? This is very generalized statement, Namrata. We have studied this in theory. Let us see who can answer it rightly. I'm waiting for your replies. So we take difference in the value of absorbances. Okay, then what about it? Yes, Mohammed is calling it rightly. No interference. Sample procedure change in pH of analyte by altering chemicals. Okay, right? देखो मैं बताता हूँ आपको क्या होता है. Anyway, I will explain you what this method is. See, just consider any compound. Okay, any compound. We are using paracetamol. Okay, paracetamol में कुछ तो impurities है. We are preparing one solution in methanol. So in methanol, the observed value of absorbance is for paracetamol plus impurities present in paracetamol. You agree with this part? What we observe is absorbance of paracetamol plus impurities present in paracetamol. Okay, now from this solution I am preparing 2 solutions. One solution I made in acidic media, the other solution I prepared in basic media, जैसे हमने practical में आज किया. Okay, so in acidic media, the absorbance of paracetamol is changing, but absorbance of that impurity is remaining the same. Absorbance of paracetamol is changing, but absorbance of impurity is remaining the same. So whatever observed absorbance I am getting, okay, it will be acidic media. मैंने क्या बनाया? Acidic media में solution में. Let me write this. So absorbance in acidic media is equal to absorbance of paracetamol in acidic media plus absorbance of impurities in acidic media. Now, similarly, I am preparing the solution of the same paracetamol in base. Okay, so it will be absorbance of paracetamol in basic media plus absorbance of impurities in basic media. Now, the assumption or prerequisite for difference spectroscopy method is these two absorbances of impurity and absorbance of impurity in base, they should be equal. If this is true, then only we can apply this method. तो होता क्या है? What we are doing? We are subtracting absorbance of paracetamol in basic media minus absorbance of paracetamol in acidic media. हम वही तो करते हैं. When we take delta A, we do the same thing. You agree with me? You agree with me? हम delta A जब लेते हैं, हम यही तो करते हैं. Okay, so here I have written down only the left hand part of the equation. So it will become absorbance of paracetamol in basic media minus absorbance of impurities in basic media, now minus absorbance of paracetamol in acidic media minus absorbance of impurities in acidic media. But these two terms are equal, so they will get cancelled out. So overall, what we are left with? Absorbance of only paracetamol and nothing else in the basic solution minus absorbance of only paracetamol in acidic medium and nothing else. So we are eliminating the interference by impurities. We are eliminating interference by impurities. So this is how the requirement of this method is helping in the experiment. Have you understood this logic? Has everyone understood this logic? Excellent. If you have understood, just type down your roll number. We'll start with roll number 23 and then you can disconnect. अगर कुछ doubt रहेगा, you can stay back after everyone has left. I will solve it out. Type down your roll number and then you can disconnect. Sir, can you please explain about C standard? Sushmita, please unmute कर. तुला काय exactly विचारायचं आहे मला नाही समजलं.
सर ते कॉन्सन्ट्रेशन ऑफ स्टँडर्ड जे आलं ना ते कॅल्क्युलेशन ऍक्च्युली थोडं डाऊट आहे. कॉन्सन्ट्रेशन ऑफ स्टँडर्ड.
अच्छा, तुला मी कॅल्क्युलेशन परत सांगू का?
येस सर, शॉर्ट मध्ये.
हा ठीक आहे. जस्ट अ सेकंड ना, मला चेंज करते हे. सर कुठे गेला? तुला हे कसं आलं ते विचारायचंय का? See, this is to understand this I need to tell you this also. Okay, so this is delta A of standard. Okay, this is a delta A of standard. It is equal to delta absorptivity of standard into path length into concentration of standard. So it is nothing but delta A of standard is equal to delta absorbance of standard divided by concentration of standard. So ही व्हॅल्यू तुम्हाला ऑब्झर्वेशन मधनं मिळालेली आहे आणि हे किती आहे? कॉन्सन्ट्रेशन ऑफ स्टँडर्ड 1 मायक्रोग्राम पर ml. यू एग्री विथ मी?
ही कॉन्सन्ट्रेशन ऑफ जे स्टँडर्ड आहे ना, ते डायल्युशन स्कीम ऑफ स्टॉक सोल्युशन मध्ये मधून जे मिळेल कॉन्सन्ट्रेशन ऑफ स्टँडर्ड.
बरोबर ना, ते तिथूनच आलंय.
ते कसं आलं एकदा प्लीज रिपीट करा ना.
अच्छा, तुला डायल्युशन तुला पाहिजे?
येस सर, ते स्लाइड डायल्युशन स्कीम फॉर स्टॉक सोल्युशन.
स्टॉक सोल्युशन स्टँडर्डचं का सॅम्पलचं? स्टँडर्डचं. हे पाहिजे का तुला? हे बघ, सी याच्यामध्ये आपण 100 मायक्रोग्राम पर ml आपण त्याचं हे म्हणतोय, काय म्हणतोय? स्टॉक सोल्युशन म्हणतोय. म्हणजे एका ml मध्ये किती असणार आहे ड्रग? 100 मायक्रोग्राम.
एका 100 मायक्रोग्राम.
Okay, so let us consider this as 100 microgram. Now this 100 microgram is dissolved in 10 ml. त्याचं कॉन्सन्ट्रेशन काय येईल? 100 microgram
10
divided by 10. So it becomes 10 microgram per ml. Excellent, excellent. Okay. आता ह्या 10 मायक्रोग्राम पर ml मधनं आपण 1 ml घेतलं. मग याच्यामध्ये या 1 ml मध्ये किती ड्रग असेल?
1 मायक्रोग्राम पर ml. त्या 1 ml
हा बोला बोला, विचार करा पाटील भाई, विचार करा. मी काय लिहितोय तिकडे बघू नका.
या 10 ml मधून 1 ml घेतला.
हे बघ, ह्या 10 ml मधनं 1 ml घेतलं, त्याचं कॉन्सन्ट्रेशन काय आहे? 10 मायक्रोग्राम पर ml.
पर ml.
हा, मग 1 ml मध्ये किती असेल?
1 मायक्रोग्राम पर ml.
अरे बाळा,
सेम 10 मायक्रोग्राम पर ml.
येस, तू ह्याच्यातनं ह्या सोल्युशनचं कॉन्सन्ट्रेशन आहे 10 मायक्रोग्राम पर ml. जेव्हा आपण म्हणतो पर ml, या गोष्टीचा अर्थ काय की त्याच्या प्रत्येक ml मध्ये 10 मायक्रोग्राम
पर ml.
हा, मग आपण 1 ml घेतलं, त्याच्यात ड्रग किती असेल? 10 मायक्रोग्राम.
10 मायक्रोग्राम पर ml.
ओके, कॉन्सन्ट्रेशन आणि क्वांटिटी मध्ये तुझी गडबड होते बरं का. जेव्हा आपण कॉन्सन्ट्रेशन म्हणतो तेव्हा ते फक्त मायक्रोग्रॅम, मिलीग्रॅम, किलोग्रॅम मध्ये असतं, आणि जेव्हा कॉन्सन्ट्रेशन म्हणतो तेव्हा मायक्रोग्रॅम पर ml असतं. परत सांगतो, क्वांटिटी असेल तर ती फक्त मिलीग्रॅम, मायक्रोग्रॅम, किलोग्रॅम, ग्रॅम असेल. हा, आणि जेव्हा कॉन्सन्ट्रेशन असतं तेव्हा मायक्रोग्रॅम पर ml, मिलीग्रॅम पर ml, ग्रॅम पर ml. ओके, तर मी तुला विचारत होतो क्वांटिटी किती असेल, तर ती असेल 10 मायक्रोग्रॅम.
10 मायक्रोग्राम.
हा, 10 मायक्रोग्रॅम आता हे 1 ml मध्ये घेतलं आणि 10 ml मध्ये मेकअप द व्हॉल्यूम केलं. म्हणजेच काय झालं, हे जे 10 मायक्रोग्रॅम आहे, इट इज नाव प्रेझेंट इन 10 ml. मग आता याचं कॉन्सन्ट्रेशन काय होईल?
1 मायक्रोग्राम पर ml.
एक्सलंट, याचं कॉन्सन्ट्रेशन आहे 1 मायक्रोग्राम पर ml. व्हेरी गुड. कळलं तुला हे कसं आलं?
येस सर. येस.
ओके, आता ही जी गोष्ट आहे ही आपण अजून एका पद्धतीने करू शकतो. हा, जे मी तुम्हाला ऑलरेडी शिकवली आहे. आता मला सांग, हे सोल्युशन बनवण्यासाठी आपण काय करतो आहे? 10 मिलीग्रॅम ऑफ पॅरासिटामॉल घेतोय अँड वी आर डिझॉल्विंग दॅट 10 ml इंटू 100 ml. एम आय राईट?
येस.
आता 10 mg म्हणजे हे किती मायक्रोग्राम झालं? हे
10,000 मायक्रोग्राम. 10,000 मायक्रोग्राम.
व्हेरी गुड, व्हेरी गुड, व्हेरी गुड. ओके, सो can I apply that formula ABC
X Y Z
upon X Y
Z?
So if I apply the formula, will I get the same answer in micrograms per ml? इथे बघ कसं होईल. 10,000 multiplied by 1 multiplied by 1 divided by
10,000.
100 multiplied by 10 multiplied by 10. So
4 zeros cut. 1.
Okay, have you understood this now?
Yes sir.
ठीक आहे, अजून काही डाऊट आहे का तुला?
नो सर, एवढंच डाऊट.
ओके,
ओके, थँक्यू सर.
या वेलकम.
येस सर.